Alright, so we are on 2.3. Today we are talking about rotation. So our goal here is that I can rotate figures in the coordinate plane. Our warm-up, something very easy. Things that rotate about a point in the center of the object. If we think of some examples like a wheel, will be something that rotates in the center of an object. What's something else that might rotate around the center? Dusty? Huh? What do you mean? How's a triangle rotate? Something real life. A wheel's a real life example. You have a wheel, it goes around its axis. Okay, is a donut rotating around something now? Okay, it can't. Guys, I'm not asking you to give me examples of things that we can rotate. I can rotate anything around the center point. What I'm asking you is, what is a real life example of something that already does it? Aiden?
A camshaft.
Okay, a camshaft. I know, it's part of a car. Shh. Okay, the blades of a fan. The fan blades do. Dusty? The clock, that's the one I was thinking. Okay, we're going to stop with those. Alright. Things that rotate around the point that's not in the center of the object. This one could be a little more tricky. It's not in the center of the object, like windshield wipers. Those rotate, but they're not in the center of the wipers. They're on the edge. Good. A door doesn't necessarily rotate around the center. It's on the edge. Any other ideas? Okay. So today we're going to talk about objects in our coordinate plane that are going to rotate. Now, here's the question. On all those things that we just mentioned, when we rotated them, did we change Dylan? That's going to be your one warning. Do we change the shape of them? Do we make them bigger? Do we make them smaller when we rotate them?
Nope.
No. Do we relocate them?
Yes.
Maybe. It depends on how we're going to look at it. If I'm looking at a wheel, well, a wheel stays, it just goes in a circle. I'm not moving it from here to here. It moves when it moves the car. But for the most part, with the center point, it's going to stay where it's at. So, here's what you're going to do first. I want everyone to... Let me open up my sphere so I can show you. You need to turn to this in our notebook. And I'll maybe give this to you. But I need everyone to turn to this point. Right. No more. You're talking about things that are not with our math. So, 2.3 rotations exploration. So I want you in one of the coordinate or one of the quadrants, draw either a triangle or a rectangle. We're going to do this just a little different. Just like we did last time. Dusty, turn around, buddy. They don't need you back there. All right.
I need none of that. I need one of those too. Harrison, stay focused on math. All right. We should draw a triangle somewhere on here. I'm going to go ahead and draw my triangle. I'm going to make a right triangle. Now, once you made your triangle or your rectangle, your instructions tell you to use your transparency paper. I told you to hold on to yours last time. Okay? You need to use your transparency paper. I'll give you one more copy if you don't have it. But I'm going to give you only one more, and then I'll give you guys clips that we need to keep track of them.
So, does anyone need the transparency?
Me, please. You.
You probably didn't figure it out there. Brett, come sit up here, bud. I'll find a better spot for you. It looks like that's being too hot. You're just constantly doing other things. Come on. You can sit here for now. Alright. Now, it says to use your transparency paper. I'm going to put this on there. And I'm going to copy my shape. And I'm going to copy the axis and origin. If you had your original piece, you could have already done that because your axis and origin should have been there. And I'm going to copy this on, and then it says what I want you to look at with your partners. I'm going to pause the video for just a few minutes, actually probably about a minute or two. And I want you to follow the instructions that says turn. When you're turning this, keep the origin there in the middle, but I want you to turn it so your axis switch. So my axis switch. And I want you to see, what can we figure out? What do we learn about where the shape's at? Think about the coordinate points. Okay? Alright, so mine's kind of messy, so I might fix it later. But what I did, and what we should have learned here, and this is the reason we do exploratory, so you guys should be starting to visually see this, is when I took from quadrant 2 and I turned it to the right, I went into quadrant 1, I noticed that my point for all my vertices, I'm going to push this down, you can see it looks like this. Try to hold that there. So you can see what happened was we rotated around that center part and everything stayed the same. Focusing up here. And it turned out my triangle's on its side. But if you notice, it stayed the same distance from the one axis. It's just that axis has turned. Right here, if you look at the board where I'm showing with my fingers, here was the x-axis divided my triangle. When we turn that, that's that same distance, which is now the y-axis. So if I turn it just 90 degrees, and I go from one quadrant to the other, that means I switched my axis. I switched which axis is my x and which one's my y. So when I look at my coordinate points, that would make sense. For my A point, before it was -5, 6. When I went to quadrant 2, the two coordinates flipped because I changed which axis is which. It became 6, 5. For B, -5, 3 became 3, 5. So when I turn 90 degrees, one thing I'm going to notice is it's turning my coordinates. It's flipping my coordinates around. But then I have to pay attention to what quadrant I am in, whether my coordinates will be positive, negative, 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 positive, negative, negative, positive. That has a little effect on it. Okay? Even when I look all the way, when I flipped 2 turns, which means I turned 180 degrees. I made this turn 180 degrees. I went 90 and 180. If I look at what happened, my coordinates were the exact same as my original. Oh, that's okay. That's okay.
You keep going.
Awesome. So my coordinates stayed the same.
but they change whether they are positive, negative, or negative, positive. All right? Let's go back into here. All right. Turn back to your foldable for me. And we should be on rotations. I gotta zoom out now. Aiden, staying with math. All right, everyone should be opening up their foldable. Jordan, hi, buddy. Everyone should be on rotations. It's your purple sheet. All right, we are gonna put this in there. So, rotation is a transformation in which a figure is rotated about a point called the center of rotation. The number of degrees that figure rotates is called the angle of rotation. And we need to make sure we have all that copied into our notes so we can break it down what it means. So I'm going to steal mine. It is a transformation in which a figure is rotated about a point called the center of rotation. The number of degrees a figure is rotated is called the angle of rotation. And then also called a turn. Okay, one part that I want you to add into this, probably just draw it right next to it, is when we talked about the angle of rotation, what we're going to first discuss, oops, I don't want to use that color, is let's make our little coordinate grid right quick. Just draw that on there, and I'm going to add in here, I'm just going to say I'm going to start right here. Now, when we rotate something, and what we're going to work on today, what does it mean if I'm going to rotate it clockwise? Can anyone come draw the arrow? What's that going to show me? Which way am I going to turn it? Will? Which way are we going to turn it clockwise? Awesome. Thank you. I'm going to write this up here. Okay. Aiden, Harrison. Last one. So clockwise, we're going to be turning them to the right. It's just like if I took a clock and I put it right down on top of it. Okay? So we'll turn this way. Counterclockwise, obviously, is our opposite direction. If you want to put that in here as well, you can. So I'm going to start here and I'm going to say, I don't know, I lost everything. So we'll say this is counterclockwise. Okay, identifying rotation. So this should be on your foldable, right? I want you to use your transparency paper to help you. Go ahead and put your transparency paper on the first example. You should already have your coordinates, your lines, your X and Y axis. Put that on there. Let's trace that first shape. Go ahead and trace that puzzle piece. I should see people putting a transparency paper on there and tracing it. This is what's going to help you for now. And what does it mean by 270 degrees? How can we find out how much that is? Kinda.
what I would think of is right here, if we have our coordinate graph, this is broken into kind of square units. When we turn 90 degrees is going to be like this. Every time we turn to one of the other quadrants, we are turning 90 degrees. Okay? So I'm going to turn 270 degrees clockwise. So how many do you think? Let's get to that, Kemper. If I turn one time, that's how many? So if I turn twice, that's... If I turn 3, that is... 180 plus 90. 270. So we're really going to take this one, and I need to take this piece, and I need to turn it 3 times, meaning here's 1, here's 2. I need to have this piece end up over here. What will that piece look like? How many people think it's going to look like piece A? How many people think piece B? Couple. How many people think C?
It would be.
And who thinks D? Okay, here's the one thing I would do. I know for sure it's not D. Or not D, sorry. Oh yeah, I know it's not D because that'd just be a reflection. There's 2 ways to solve this. One, if you did your puzzle piece on there and you turned it, you could have got it, which it would have ended up being C. Now, does everyone have it on their transparency paper and they see it being C? Okay, I want to make sure. I'm going to show this. We have to make sure we're understanding this. This is a big part of today's. So, what I should have seen you do, if I took my piece, like this. Here's 1 turn. Here's 2. There is 3. So I had to match it with that one. That is our rotation. Remember, we did rotate it 3 times. Oh, guys, we're in a lot of trouble focusing. I might have to redo our seating chart already and just spread some of these gentlemen out. It's not the ladies that are having a problem with that. Yeah. Alright, so when it rotates 3 times, go back to what I stated up before with our first, that was with our one example, our notebook. 3 times means our x-axis and y-axis switched. The C is our correct answer. Let's look at this one. Which one would be 180 degrees around the origin? If you need your transparency paper for today's assignment, I would use it. Brett, what would it be? How many turns is 180 degrees? Huh?
2.
Good. So I'm going to think 2 turns. If I turn it once, it would have been up here. Twice. So which one did you say? Let's see. Boom, boom. B would have been your correct answer. Seriously, guys, have your planner up. You're not even looking to follow along with us. It's in your notebook. You're not doing it with us. You guys are talking the whole time. We just did another example. You didn't participate. You never looked up once up at the board. But I kept hearing you guys talk. Okay. I'm going to stop at this point. For today, our goal was mainly that I can identify a rotation and I can rotate a figure around a point. Tomorrow, we're going to continue with rotations, but we are going to throw in the coordinate points. You have a transparency paper. I've given everyone one. You may need to use it for your homework today. If you're not here tomorrow, we'll do it on Thursday. Your assignment, due the next day I have you. Why didn't I go to this? 2.3 says describe relationship. Describe the relationship between the given points and the point 2,7. I know some of you are going to miss this because you're not picking this part up in the instructions. 1 point is at 2,7. If it became 7, -2, how did I rotate that? I'm asking you to tell me clockwise 90 degrees, clockwise 180 degrees, clockwise 270 degrees, clockwise 360 degrees. Okay? Hopefully you heard that. I'll say it one last time. Evan, Noah, make sure you're listening to this. On 6, 7, and 8, you were telling me you're turning it clockwise and how many degrees? The one we are working on is only 90, 180, 270, 360. Where we're turning it 1 turn, 2 turns, 3 turns, or 4 full turns. 9, 10, 11, and 12, you have to tell me whether the figure is a rotation. If so, give the angle and direction. Same thing as this first one. So, on 9, 10, 11, 12, you're going to say, yes, it's a rotation. And then you'll say, clockwise 90 degrees. Or clockwise 270 degrees. Okay? Do not forget that second part. You do not get a completion grade if I do not see all of that. You have to have all of it. Any questions? All right. Hopefully I'll see you